Hello students, I am Rizwan. In the diagram given in figure, triangle DEF is formed by joining the midpoints of the sides AB, BC and CA of triangle ABC. Then the size of the triangle DEF is exactly the 1/4 of the size of triangle ABC. Similarly, triangle GHI is also 1/4 of triangle FDE and so on. In general, the successive areas are 1/4 of the previous areas. The area of these triangles is ABC. 1/4 of triangle ABC, 1/4 into 1/4 into triangle ABC, that is triangle ABC, 1/4 of triangle ABC, 1/16th of triangle ABC and so on. In this case, we see that beginning with triangle ABC, we see that successive triangles are formed whose areas are precisely 1/4 the area of previous triangle. So, each term is obtained by multiplying 1/4 by the previous term. As another case, let us consider that a viral disease is spreading in a way such that at any stage two new persons get affected by an affected person. In the first stage, one person is affected, in the second stage, two persons are affected and it spreads to 4 persons and so on. Then the number of persons affected at each stage is 1, 2, 4, 8, so on, where except for the first term, each term is precisely twice the previous term. From the above example, it is clear that each term is got multiplying a fixed number by the preceding number. This idea leads us to the concept of geometric progression. Learning outcomes. After the completion of this lesson, you will be able to define geometric progression, understand general terms of geometric progression. Keywords from this lesson are numbers, series, sequence, first term, last term, common difference, common ratio, successive terms, consecutive terms. Definition. A geometric progression is a sequence in which each term is obtained by multiplying a fixed non-zero number by the preceding term except the first term. The fixed number is called the common ratio. The common ratio is usually denoted by R. General form of geometric progression. Let A and R not equal to 0 be real numbers, then the number of form A, AR, AR square, so on, AR power n minus 1, so on is called a geometric progression. The number A is called the first term and the number R is called the common ratio. We note that beginning with the first term A, each term is obtained by multiplying with the common ratio R to give AR, AR square, AR cube, so on. General term of geometric progression. We try to find a formula for nth term or general term of geometric progression whose terms are in the common ratio. A, AR, AR square, so on, AR power n minus 1, where A is the first term and R is the common ratio. Let Tn be the nth term of the geometric progression. Then T1 is equal to A. T2 is equal to A into R. T3 is equal to AR square. So on, Tn is equal to AR power n minus 1. Thus, the general term or nth term of a geometric progression is Tn is equal to AR power n minus 1. Note, if we consider the ratio of successive terms of the geometric progression, then we have T2 by T1 is equal to AR by A, which is equal to R. T3 by T2 is equal to AR square by AR, which is equal to R. T4 by T3 is equal to AR cube by AR square, which is equal to R. T5 by T4 is equal to AR power 4 by AR cube, which is equal to R, and so on. Thus, the ratio between any two consecutive terms of the geometric progression is always constant, and that constant is the common ratio of the given progression. Let us see one example. Which of the following sequences form a geometric progression? Solution. To check if a given sequence forms a geometric progression, we have to see if the ratios between successive terms are equal. Sequence 1, 7, 14, 21, 28, so on. Now we will find the ratios between the successive terms, that is T2 by T1 is equal to 14 by 7, which is equal to 2. T3 by T2 is equal to 21 by 14, which is equal to 3 by 2. T4 by T3 is equal to 28 by 21, which is equal to 4 by 3. Here, the ratios between successive terms are not equal. The sequence 7, 14, 21, 28, so on is not a geometric progression. Sequence 2, 1 by 2, 1, 2, 4, and so on. Now we will find the ratio between the successive terms, that is T2 by T1 is equal to 1 by 1 by 2, which is equal to 2. T3 by T2 is equal to 2 by 1, which is equal to 2. T4 by T3 is equal to 4 by 2, which is equal to 2. Here the ratios between successive terms are equal. Therefore, the sequence 1 by 2, 1, 2, 4, so on is a geometric progression with a common ratio R is equal to 2. Sequence 3, 5, 25, 50, 75, and so on. Now we will find the ratio between successive terms, that is T2 by T1 is equal to 25 by 5, which is equal to 5. T3 by T2 is equal to 50 by 25, which is equal to 2. T4 by T3 is equal to 75 by 50, that is equal to 3 by 2. Here the ratios between successive terms are not equal. Therefore, the sequence 5, 25, 50, 75 is not a geometric progression. Let us see one more example. Find the geometric progression whose first term and common ratios are given by a is equal to minus 7 and r equal to 6, a equal to 256 and r equal to 0.5. Solution. The general form of geometric progression is a, ar, ar square, and so on. Given a is equal to minus 7 and r is equal to 6. So, a is equal to minus 7. AR is equal to minus 7 into 6, which is equal to minus 42. AR square is equal to minus 7 into 6 square, which is equal to minus 252. Therefore, the required geometric progression is minus 7, minus 42, minus 252 and so on. Second question. The general form of geometric progression is AR, AR square and so on. Given A is equal to 256 and R is equal to 0.5. So, A is equal to 256. AR is equal to 256 into 0.5, which is equal to 128. AR square is equal to 256 into 0.5 whole square, which is equal to 64. Therefore, the required geometric progression is 256, 128, 64 and so on. Let us see another example. Find the eighth term of the geometric progression 9, 3, 1 and so on. Solution. To find the eighth term, we have to use the nth term formula, that is Tn is equal to A into r power n minus 1. We know that first term A is equal to 9 and common ratio r is equal to T2 by T1, which is equal to 3 by 9, that is 1 by 3. So, T8 is equal to 9 into 1 by 3 whole power 8 minus 1. T8 is equal to 9 into 1 by 3 whole power 8 minus 1. That is equal to 9 into 1 by 3 whole power 7. By solving, we get 1 by 243. Therefore, the eighth term of the geometric progression is 1 by 243. Let us see one more example. In a geometric progression, the fourth term is 8 by 9 and the seventh term is 64 by 243. Find the geometric progression. Solution. Given for fourth term T4 is equal to 8 by 9, from formula we can get AR cube is equal to 8 by 9. Consider it as equation 1. Similarly, for seventh term T7 is equal to 64 by 243. From formula we can get AR power 6 is equal to 64 by 243 as equation 2. Dividing equation 2 by 1, we get AR power 6 by AR cube is equal to 64 by 243 by 8 by 9. That is equal to 64 by 243 into 9 by 8. By cancelling we get r cube is equal to 8 by 27, that is equal to r equal to 2 by 3. Substituting the value of r in equation 1, we get a into 2 by 3 whole cube is equal to 8 by 9. By solving, we get a is equal to 3. Therefore, the geometric progression is a, ar square and so on. That is 3, 2, 4 by 3 and so on. Note: when the product of three consecutive terms of a geometric progression is given, we can take the three terms as a by r, ar. When the product of four consecutive terms are given for a geometric progression, then we can take the four terms as a by r cube, a by r, ar and ar cube. When each term of a geometric progression is multiplied or divided by a non-zero constant, then the resulting sequence is also a geometric progression. Let us see one example. The product of three consecutive terms of a geometric progression is 343 and their sum is 91 by 3. Find the three terms. Solution: since the product of three consecutive terms is given, we can take them as a by r, a and ar. Product of the terms is equal to 343, so a by r into a into ar is equal to 343. Now a cube is equal to 7 cube. By cancelling, we get a is equal to 7. The sum of the terms is equal to 91 by 3. Hence, a into 1 by r plus 1 plus r is equal to 91 by 3. Now substitute a value, that is 7, to find r value. From this we get 7 into 1 by r plus 1 plus r is equal to 91 by 3. By multiplying and solving, we get a quadratic equation, that is 3 plus 3r plus 3r square is equal to 13r. By simplifying, we get 3r square minus 10r plus 3 is equal to 0. By factorizing, we get 3r minus 1 into r minus 3 is equal to 0. From this, we get r values as r is equal to 3 or r is equal to 1 by 3. If a is equal to 7 and r is equal to 3, then the three terms are 7 by 3, 7 and 21. If a is equal to 7 and r is equal to 1 by 3, then the three terms are 21, 7, 7 by 3. Points to remember: geometric progression is a, ar square, so on, ar power n minus 1. Nth term is given by Tn is equal to ar power n minus 1. The numbers of form a, ar square, so on, ar power n minus 1 is called a geometric progression. The number a is called the first term and the number r is called the common ratio. The ratio between any two consecutive terms of the geometric progression is always constant, and that constant is the common ratio of the given progression. Thanks for watching.